So let's do one more example problem of two objects that are moving, a cat and a rat. So let's say that we've got a cat here. Okay, so we got a cat and we got a rat. And the rat is running at a velocity. We'll call the rat object 2 and the cat object 1. So the velocity here, to make the math easy, we're going to say 2.61 meters per second constant velocity. The cat is initially at rest and starts accelerating here with an acceleration of 3.55 meter per second squared. Initially, when the cat starts running towards the rat is a distance of 1.25 meters away. So again, we're in chapter 2 of the textbook, which is one-dimensional problems. So we'll make this a one-dimensional example. So I want to know, how far does the rat run, x2, before the cat catches him? Okay, so how do we do this? Well, we know that x2, again, we got our equation. Okay, x equals x naught plus v naught t plus 1/2 at squared. Okay, and so x2 here is going to be pretty straightforward. Okay, the acceleration is 0. If we put our origin there and say that the initial x position is 0, then x2 is just going to be v2 times t. What about the cat? The cat runs a much farther distance. Okay, so the cat has to close this distance here and then has to keep going because the rat was running while the cat was closing the distance. So the total distance the cat ran, okay, if we put our origin here where the cat is, okay, say x naught is 0, the cat starts at rest, so that's 1/2 a1 t squared. So what do? Well, we look at the problem and say, well, what's the relationship? Well, x1, the distance the cat went, was the original distance plus x2. Okay, so the cat had to run the original distance and then had to run the extra distance that the rat ran. Okay, so we plug in 1/2 a1 t squared equals d plus v2 times time. So 1/2 a1 t squared minus v2t minus d equals 0. Well, I can find the distance that the rat ran, v2 times t, if I knew what t was. Well, this is a quadratic equation. I can find t. So t equals v2 plus or minus the square root of v2 squared minus 4 times 1/2 a1 times d, okay, actually minus d, okay, and then divided by 2 times 1/2 a1. So in other words, t equals v2 plus or minus square root v2 squared plus 2a1 times d divided by a1. So we plug in our numbers. Okay, so 2.61 meters per second plus or minus 2.61 meter per second quantity squared plus 2 times 3.55 meter per second squared times d 1.25 meters, okay, and all that divided by 3.55 meter per second squared. So let's make sure the units work out right, because we did a bunch of algebra. Okay, if the units don't work out right, we know this didn't work. So meter over second squared right here is meter squared second squared. Meter over second squared times meter is meter squared over second squared. Meter squared over second squared plus meter squared over second squared is meter squared over second squared. Meter squared over second squared square root is meter per second. Meter per second plus or minus meter per second is meter per second. Meter per second divided by meter per second squared is seconds. So check your units. If the units do not work, you have a 100% chance of making a mistake, and you know you did it wrong, and you want to go back and find where your error was. If doing all this algebra and working all this stuff together, throwing the numbers in the equation, if the units work out right, there's actually a really good chance you got the problem right, because, at least so far, because it's really hard to just throw these numbers in randomly and come out with the right units. Okay, so do that extra step of checking your units. I know it takes extra time, but if you do that, it will save you from making a mistake. So, when we do this, we get 2 times. Negative 0.380 seconds, or a positive 1.85 seconds. Well, we know that negative time doesn't make sense. In a sense, you can think of the negative time meaning, how long before you started looking at the problem did the rat pass the cat. Okay, but in this case, we want the 1.85 seconds. So 1.85 seconds. So the distance the rat ran, x2 is v2 times time. So that's going to be 2.61 meters per second times the 1.85 seconds. And so x2 is going to be 4.83 meters. So that's how far the rat was able to run before the cat caught him. And so once again, we have another example in which we had more than one object moving. When we get to chapter 2, we're going to have one object moving in 2 different directions. So it's going to be changing in x and changing in y. Well, y, we've kind of been doing 2 objects here. We've been calling them x1 and x2, but we could have called them x and y as our 2 different variables. Remember, the algebra doesn't care what letter you use for the variable. And so this is kind of leading way into our idea that we're going to be having for later when we're talking about 2-dimensional motion. So we're still doing 1-dimensional motion right now, but chapter 4 does 2-dimensional motion. And so that's coming up.